Okay, we all know legal discovery can just be this absolute mountain of data, right?
Absolutely. Gigabytes and gigabytes.
Yeah, hundreds of gigs of emails, maybe thousands of online complaints. I mean, how does anyone find that one crucial detail, the needle in this huge digital haystack? Especially under, serious time pressure.
It seems almost impossible for a human alone, yeah.
Exactly. But what if AI could do more than just sift through it? What if it could, like, strategically find potential class action lawsuits before they even really get started formally?
Now that's getting interesting.
So today, that's what we're digging into, this really fascinating intersection of AI specifically, things called knowledge graphs and multi-agent systems and how they're impacting the legal world.
hmm
Our mission basically is to explore how these advanced technologies are, well, changing the game for discovering, researching, and ultimately building stronger legal cases.
Helping lawyers get that accuracy and insight they desperately need.
Right. And maybe even find things faster than was ever possible before. We'll unpack the challenges too, of course, but also the incredible potential here.
It's definitely not science fiction anymore.
So by the end of this deep dive, you should have a pretty clear idea of how these knowledge graphs work, turning all that messy data into something useful.
And how multi-agent systems are built for that high-stakes legal world where precision is everything.
Yeah, and we'll look at some real examples, like how everyday online chatter is actually being used to spot potential lawsuits early on.
That's a great example of where this tech shines.
Okay, let's set the scene a bit. The legal world. It operates under some really unique pressures, doesn't it?
Absolutely, the demands are incredibly high.
Perfection, absolute accuracy, getting the language exactly right. These aren't just nice to haves, they're fundamental.
Non-negotiable. Top lawyers are known for being incredibly detail-oriented.
Which is a huge strength, definitely. But it also creates this massive information challenge, doesn't it? Just dealing with it all.
It does. And what's really fascinating, I think, is that alongside that need for perfection and detail, lawyers also need tremendous creativity.
Creativity, how so?
Well, they have to take those precise details, those legal precedents, and apply them to totally new situations, cases that maybe haven't been seen before.
Ah, okay. Like connecting old ideas to new problems.
Exactly. Think about that Blockbuster versus Netflix example people sometimes use. An old case about, like, limits on physical DVD rentals
Right, from way back.
could potentially be creatively applied to how Netflix captures data today, even though it's completely different technology, different scale.
Interesting. So it's about seeing the underlying principle.
Precisely. But the core problem, like you said, is that information is scattered everywhere. And that creative knowledge, that intuition about how to connect things, it often just lives inside an expert's head.
Right, it's not written down in a database somewhere easily accessible.
Not usually, no. It's buried in documents, past cases, individual experience.
So it's not just the sheer volume of data, it's also about capturing and, I guess, externalizing that valuable creative legal thinking. Is that where these knowledge graphs you mentioned come into play?
That's a huge part of it, yes.
How do they actually work? How do they bring order to all that legal chaos?
So knowledge graphs are, at their core, about relationships,
Yeah.
connections.
Okay.
Imagine all your legal documents, emails, case law, maybe public complaints, not as separate files, but as points, nodes in a big network, with lines explicitly showing how they're connected.
Ah, so you can see the links.
Exactly, you can explicitly see what's connected to what. The insight comes from turning that mountain of separate information into a kind of roadmap.
Right, showing connections that maybe even a human expert might miss wading through everything individually.
Precisely. And we're not just talking simple connections like this document mentions that person. These relationships can be complex, multi-step, varied. They can branch out.
So pretty sophisticated links.
Very sophisticated, which makes them really powerful for messy, complex legal data. Now, visually, they can be quite intuitive. You can literally see the connections on a screen.
Yeah, I can picture that.
But the real power often comes from doing large-scale analytics on those connections, finding patterns, clusters, anomalies that you'd never spot otherwise.
So analyzing the structure itself.
Exactly.
Okay.
It used to be that graphs were maybe a bit niche. But now, with things like GraphOrg,
Grapher.
retrieval augmented generation, but using a graph to find the relevant information to feed into an AI model like an LLM.
Got it.
And just the general need for better structured data. Graphs have become, well, I'd say pretty necessary and consistently used tools. They provide that structure where, traditional databases are just lists of documents fall short.
Okay, that makes sense. But you mentioned that need for precision earlier. Lawyers need things to be exactly right.
Absolutely critical.
So how do these multi-agent systems fit in? They sound complicated. How do they maintain that level of exactness, especially when we know large language models, LLMs, can be a bit fuzzy sometimes, probabilistic.
Yeah, that's the million-dollar question, isn't it? It gets really interesting here.
Right. How do you engineer for that?
Well, multi-agent systems, especially in this legal context, are often about breaking down really complex tasks. Think about those white-collar workflows like legal research or discovery review or maybe compliance checks.
Okay.
Breaking them down into very specific, testable, controllable steps, little modules almost.
Okay, like an assembly line?
Sort of, yeah. And each step, each agent in the system might have different needs, run at different times, and crucially, it has its own defined state, what it knows, what it has processed.
And that state, is that managed by the graph?
Often, yes.
Mm-hmm.
The graph provides that underlying structure to manage the state across these different agents or steps. And why do we need all this control, this granularity?
Because LLMs aren't always right.
Exactly. Because like you said, probabilistic LMLs alone, they just don't cut it for most legal work. The industry demands specific correctness, verifiable information, the right legal language.
You can't just wing it in a legal brief.
Absolutely not. So you can't just, throw a general purpose LLM at a complex legal problem and hope it gets it right. You need very specific controls, strong structures, clear rules or schemas at every single stage.
To ensure accuracy and also to know where things went wrong if they do go wrong.
Precisely. Traceability is key.
So it's like building guardrails around the LLMs, making them work within this highly structured environment. But that sounds really challenging to build.
It is. It's definitely not trivial.
What are some of the big hurdles? What makes engineering these systems so tough for law?
Well, several things. For one, not all parts of a complex legal workflow are equally critical, right? Some steps are more sensitive than others.
Okay, so you need to prioritize.
Right. And it's also incredibly easy to write a bad prompt for an agent, maybe when using an LLM. And a bad prompt leads to, well, a bad agent, an unreliable output you just can't trust.
Garbage in, garbage out, basically.
Pretty much. So we spend a lot of time and effort on guardrailing these systems, building in checks and balances.
How does that involve?
Things like ensuring not just immediate memory for the task at hand, but what we call episodic memory.
Episodic memory, like remembering past events.
Exactly. The system needs to remember related things it did before, decisions it made, especially for legal cases that can run for months or years. Context is vital.
Makes sense.
So we're constantly, meticulously capturing information, expanding on it, pruning irrelevant stuff, structuring it, and then querying that state, the current knowledge. And usually that happens in that graph format we talked about.
Because the graph gives you the structure and the flexibility.
Yes,
Yeah.
structure and that ability to extend it as you learn more. But there's another big challenge, the decision-making under uncertainty problem.
Yeah.
Think about it. Getting a single AI agent, maybe using an LLM, to be 95% accurate on a complex task. That's already really hard.
Yeah, 95% sounds pretty good, but maybe not perfect.
Right. But now, what if your workflow requires chaining 5 of those agents together? Step 1 feeds into step 2, into step 3, and so on.
The errors compound.
Exactly. If each step is only 95% accurate, your expected accuracy for the whole chain drops to about 77%.
Wow, okay. That's definitely not good enough for most legal tasks.
Almost never. So the engineering isn't just about building individual agents. It's about designing the whole system to prevent those errors from cascading. It's about ensuring the state is consistent and somehow bringing that overall accuracy back up to the level lawyers absolutely require.
So despite these hurdles, these systems are being used.
Yes, specifically and consistently, precisely because they offer that level of control and structure that other approaches often lack.
Okay, that 77% figure, that really highlights the risk for a lawyer. How do you bridge that gap? How do you make these systems trustworthy enough? Let's talk real world. How is this actually being applied?
Yeah, good question. Let's take legal discovery, that massive data dump problem we started with.
Right, the 500 gigs of emails from the pharma company example.
Exactly. Traditionally, teams of paralegals or lawyers might try to manually review that, which is often just impossible given the deadlines in a lawsuit.
Totally infeasible.
But using knowledge graphs, you can automatically extract key information, people, dates, topics, connections, and structure it consistently.
So turning the mess into something organized.
Instantly. That huge pile of emails suddenly becomes maybe a lot of information you can quickly see is irrelevant and a much smaller focused set of genuinely useful information.
Okay, that makes a huge difference already.
And then lawyers or experts can use tools built on top of that graph. They get augmented insights, visualizations, they can ask questions in natural language,
Yeah.
and make quick data-driven decisions.
So back to the pharma example.
Right. Instead of reading thousands of emails hoping to find something at a specific chemical concentration, you could potentially query the graph and instantly see all mentions, connections, and maybe identify problematic patterns across millions of data points very quickly.
Wow. Okay, so it helps you zero in.
Massively. Zeroing in on exactly what matters instead of drowning in the noise.
What about the other side, like finding cases? You mentioned using online chatter. That sounds like finding a needle in an even bigger haystack, the entire internet.
It is, yeah. Traditionally, trying to find early signals of a potential lawsuit from just, random complaints on Reddit or Twitter or forums or even old school IRC channels.
Yeah, super noisy, unstructured data.
Extremely difficult. Our company, WHA.ai, this is actually something we do. We scrape huge portions of the web legally and ethically, of course.
Okay.
But just scraping isn't enough. The key is then qualifying potential leads, filtering all that raw noise down to what specific lawyers or law firms actually care about.
Ah, so it's personalized.
Highly personalized. We use custom schemas, custom rules, tailored for each client. Because the goal isn't usually to find the single best potential case in the world.
Right.
It's to find cases that are a good fit for that specific lawyer or that specific firm's expertise, resources, and risk tolerance.
So different firms might want completely different things flagged.
Exactly. And this is where that combination of tech really works. LLMs for understanding the text, multi-agent systems for the filtering and analysis workflow, and structured information, often in a graph, to manage it all and tailor the output.
And the output is?
Personalized reports. The multi-agent systems, guided by those consistent pruned schemas, remember, that controlled state, often using a graph build reports, structured exactly how that lawyer needs them to decide whether to take action.
That's incredible. Finding signals from just general online noise before things become formal complaints, that feels like a genuine leap.
It can be, yeah.
Let's make it even more concrete. You mentioned a case study about car fires. How does that work?
Right. Yeah, that's a fascinating one. So imagine people start complaining online because their car unexpectedly caught fire.
Which is terrifying, obviously.
Absolutely. And often the first places they go are maybe government safety websites like the NHTSA, specific car complaint sites, maybe a subreddit for that car model, or enthusiast forums.
Okay, lots of scattered places.
Exactly. So we track those sources. We scrape the complaints, structure the information, make, model, year, what happened, schematize it, and then analyze it.
Looking for patterns again.
Looking for density, really. We build what we call a density of complaints model. It basically looks at how many complaints are coming in, multiplied by the velocity, the speed at which new complaints are appearing. Like, are we seeing a sudden spike?
Ah, okay. Number plus speed equals potential signal strength.
You got it. And the amazing advantage here is speed. A large traditional law firm, they might hear about some complaints, maybe start looking into it. It could easily take 8 or 9 months before they even seriously consider filing a lawsuit.
Right. Lots of manual investigation.
We, using these systems, can often spot the initial leads, the first few complaints, in maybe 15 minutes of them appearing online.
15 minutes.
For the initial detection, yeah. And then confirming if there's a real actionable signal there. We can often do that within probably a month.
Wow. That's months faster.
A huge head start. And again, it comes back to that extensible schema, often in the graph. Lawyers can apply filters, I only care about this make and model, or only in this state or jurisdiction, and get back those tailored action-ready reports.
And you mentioned retrieval augmented generation, RAG, before. Is that used here too?
Yes, but importantly, the generation part here isn't just about chatting with an AI. It's about generating those specific, formatted, action-oriented reports that the lawyers need to actually move forward with a case.
Got it. It's about generating actionable intelligence, not just conversation.
Precisely.
Okay, so if we zoom out a bit, connect this back to the bigger picture. You said earlier that generative AI isn't necessarily better than traditional machine learning, or LLMs aren't always better than older ML systems. What does all this tell us about the future of AI then? How do these different pieces really fit together best? Is it all about synergy?
I think that's exactly the right way to think about it. Synergy. It tells us that each approach to AI has situations where it's fantastic, where it really excels.
Different tools for different jobs.
Exactly. Generative AI isn't inherently better than classic machine learning. It's brilliant for certain things, like understanding and generating human language. Traditional ML might be better for other things, like certain kinds of pattern recognition or prediction from structured data.
Yeah.
The real breakthrough, I think, that we're seeing right now, enabled largely by the power of modern LLMs, is the ability to effectively pipe together systems that used to be incompatible or just too unreliable on their own.
Ah, so LLMs act like the glue.
In many ways, yes. They provide that semantic understanding, that conversational interface, that allows us to connect different specialist AI components, maybe a traditional ML model for risk scoring, a graph database for relationships, an LLM for summarizing text into a single end-to-end workflow.
Something that delivers value from start to finish.
Exactly. An end-to-end value proposition that often just wasn't feasible before because the pieces couldn't talk to each other effectively, or the probabilistic nature of one part made the whole chain too unreliable.
And the graphs and the state management are key to keeping that chain reliable for something like law.
Absolutely crucial. That iterative process of building the graph, pruning it, managing the state precisely across different agents. That's why these systems can consistently deliver those tailored, accurate, and improving results that lawyers need. It's about orchestrating all these different AI strengths together.
Okay, so wrapping this up for you listening.
Huh.
The core idea here is that technologies like knowledge graphs and multi-agent systems are really changing how legal pros handle this overwhelming amount of information.
Yeah, they're tackling that information overload head on.
They're helping ensure accuracy, which is paramount, but also enabling really creative legal strategies, basically turning huge piles of unstructured data into actionable, personalized insights.
And finding potentially significant issues, like those car fires, with speeds that were just unimaginable before.
It's about finding the critical signal in the noise much faster and more reliably.
Definitely. Which leads to an interesting thought for you.
Okay.
As we see these AI systems getting better and better at managing and structuring enormous amounts of complex information for really high-stakes fields like law, where else could this apply? What other industries, maybe even your own, could be transformed by this same ability? The ability to find those precise critical needles in massive haystacks and then act on that information with real confidence.